Good afternoon, everybody. My name is Sammy Arbid. I'm from Western Allied Corporation. A little bit about me and the company. I'm a controls engineer, programmer by trade. Studied computer science at Cal Poly Pomona in California. And I joined Western Allied about 13 years ago. We're a design build contractor, mechanical contractor with a controls division. So, we're largely responsible for making sure that making sure that not only do we build a system that the customer is happy with, but that it works and works for a very long time. A lot of the key points that David Knipkamp was talking about in his last presentation are philosophies that we kind of live by. We like to guarantee our customers have the lowest cost of ownership of any control system we build. That is a kind of a key value we impart in all of our systems. So with that in mind, we're kind of excited to show you guys something that we've been working on for some time now. We've been calling it multi-protocol controls. There are a number of vendors that are involved in building the hardware. We have a few of them here. These are the ones that Western Allied uses. So these are the ones that we've become familiar with, but there are others. David mentioned that there were kind of two key aspects to what we're calling the 100-year building control network. One of those aspects was the physical media. The other was the communication protocols. I'm going to actually address his second part first, the communication protocols. One of the most important things that we find in building a control network is that it is upgradable. We need to be able to provide technologies for today that could be upgraded over time without rip and replace. I know that there's no shortage of manufacturers out there that their ears hurt when I say that, because that directly affects their business model. We're here today to say we're supporting the building owners. Those are our customers, right? We're a contractor. We're not here to necessarily sell product just because a manufacturer says so. No, we're here to install product that the customer requires for their operations. And we see ourselves as part of that operation, right? We're an extension of their operation. So, communication protocols. There are three large ones, right, in the open market, right? There's Modbus. It's been around forever. Probably will never go away. It's a great protocol. The second is LAN talk. It's been around for probably 30 years now. Solid, highly specified. And of course, BACnet. I'm sure you guys are all very familiar with BACnet. What's interesting here is that we're showing a combination of both LAN and BACnet on single devices. These are devices that are able to communicate LAN and BACnet simultaneously. There's no gateways. There's no translation between the protocols. The controllers themselves, the devices themselves, have the ability to communicate both LAN talk and BACnet simultaneously. I'm going to show you exactly how it's done. So first, I want to prove it to you a little bit. We have a Niagara system set up here. In this Niagara system, we have a BACnet network and a LAN network. The BACnet network is what we're showing here, has some of these devices. And in fact, you can see their addresses. And if we dig into the points, you'll see their live values. And we'll do that. If I go into the LAN network, you'll notice these two right here, these AHR1 and 2, are also exposed in LAN network. It's the same exact device, exposed multiple ways, because it has multiple communication stacks. It's not bound to a single stack. This can go into a LAN network, this can go into a BACnet network, or we are actually combining the two in most of our jobs today. We are providing the best of both. We find that there are certain LAN features that we love and some BACnet features that we love. And with both stacks available to us, we add more value by having a control network that can do both. So this is the LAN network now. It's switched over, and we have those same devices here. And in fact, there's also a VAV controller. And not only can it speak BACnet and LAN, it speaks BACnet IP. Speaks BACnet IP with no Ethernet. This is BACnet IP over a twisted pair. You can take twisted pair from device to device to device, and it's speaking BACnet IP. In addition, of course, it has BACnet MSTP. You know, everybody has BACnet MSTP in their buildings. You know, you have to be able to provide some kind of BACnet MSTP solution. But this BACnet IP solution is fundamentally groundbreaking, I would say. So here's what we have. We have a little demonstration, little web page. It shows an input and output point on every single communication protocol. BACnet IP, BACnet MSTP, and LAN talk. If I write to any one of these, they all update. I'm going to do BACnet IP first. So just put in a value of 100, save, and you'll see that it immediately populates on the others. And MSTP, there we go. MSTP is a little bit sluggish sometimes. So I'll do the same thing here, MSTP, save. Great. I want to show you exactly how we actually implemented that, because this is something really unique. If I go into the application for the controller itself, let me actually connect onto the network with this utility. This is the programming tool that's provided by Smart Controls for their controllers to do multi-protocol programming. Let me just select the right system. Okay, great. Oh, and of course I have to debug. Oh, I connected incorrectly. Bear with me, sorry.
So Sammy, I just want to be clear, you're communicating BACnet and LAN and BACnet IP on the same communication channel, same twisted pair channel.
The same exact twisted pair channel. That's exactly right. Let me see if I selected the right network now. I apologize. I thought I had this connected previously, but I did not. Okay, I'm sorry. Give me 1 second here. I have the wrong connection. Okay. Yes, that's exactly why. Okay. Detach. Sorry for the delay. Sorry, guys. Those BACnet and LAN talk points are defined in blocks in this application. If I click on one of these blocks, for example, this one, I've created a LAN network variable called analog or iAnalog. We use an internal naming scheme. I's are prefixed for input points. So this is an input analog point in LAN talk. And then there's a BACnet object also defined. And it's as simple as that. You create your LAN talk point by identifying a network variable here. You choose your snippet type. And for BACnet, you select your BACnet object name. and your object type. You load that into your controller, and it now has the capability of talking both LAN and BACnet for that single point. This is the same exact memory location, the same exact memory address in the application that has been exposed in both LAN and BACnet simultaneously. Okay, so if I were to write to this, I'm going to write in LAN this time, and here, I'll write a 22. You'll see that the debugger immediately switches to a 22. It shows it in live. It is the same exact memory address. That is what is fundamentally unique. So how are these stacks selected? You might want to have just a BACnet IP stack selected or just a BACnet MSTP stack selected. In your program, you pick. If you double click, to select what kind of controller you're going to be building on this. You can also select your communication stack. It has both MSTP capabilities, BACnet IP capabilities, and LAN talk. So you can enable these, disable these as you like. One of the benefits of LAN talk is a common programming methodology called bindings. How many of you are familiar with what a binding is? Binding. How many of you have never heard of a binding? Okay. In the BACnet world, the majority of communications is polled. In order for a piece of information to go from one controller to another controller over the network, it's typically polled. A global controller or some kind of gateway device will take that information that it's polled and write it down to another controller. With free topology and multi-protocol controls, the sending device can publish the message without any other third-party device involved. Any device has the ability to publish onto the network to any other device on the network. No polling needed whatsoever. So we have a demonstration of the benefits of that. I have a webcam set up here, and you can see down below, there are some lights. We have an FT light, MSTP light, Ethernet light. What we're showing here is that the communications for FT, because of this binding concept or direct messaging from device to device, has huge performance improvements over polled networks. The MSTP network and the BACnet IP over Ethernet network are polled. And when I press this network button over here, the lights will turn on. What this is simulating is a message from a network switch to a networked light and the latency between it. If I hit network, FT switches on immediately. And MSTP and then Ethernet followed shortly after. I'm going to do it again. You can see FT is just like near time, just real time. In fact, I can just flip this back and forth all day long, and FT is always on it. So what we've discovered is that with about 60 milliseconds is about the latency you can have in lighting. Beyond 60 milliseconds, the person, the occupant, observes the delay and may hit the switch again. And so it creates all kinds of issues with control networks. They think that the network has failures when it's just really latency on the network. So FT is a very viable solution for lighting. It's used for real-time applications like that regularly. How many are you familiar with MSTP? Right, RS-45 networks, right? What's the number one issue on RS-45 networks, in your opinion? Speed, okay. Throughput, okay. What do you think? Have you had to deal with them? No? What's that? Latency? Okay. How many of you had to install an MSTP network? Yeah, yeah. Extremely sensitive to grounding, right? One of the hallmarks of FT is that it's actually quite insensitive to grounds. What I have here is a device that I'm going to change its ground slightly. I'm going to add just a 100 ohm resistor, elevate its ground, and you're going to see that immediately MSTP drops out. We're using the Jace here as our MSTP master, and these are the lights. This orange light in particular is the communications light. So I'm actually going to put this resistor right in series with the power, the 24 volt common, which will elevate its ground slightly. And immediately you'll see, boom, it dropped out immediately. 100 ohms is all it takes. It's actually less, but we chose 100 ohms to start making that COM bus drop out. And you'll see it'll come in and out, but it's extremely intermittent now. Whereas before, if you guys had noticed, it was solid on and talking. So if any of you have had issues with your communication bus, your MSTP bus, I mean, almost always check the grounds. It's extremely important. I'm going to take this back out, and you'll see that the MSTP bus goes back to normal. FT has no concern for grounding whatsoever. Because of the way it works, it doesn't use amplitude modulation at all, right? MSTP looks at a waveform, and the amplitude defines when it goes to a high or a low, and that's how it can read the value. FT, on the other hand, uses frequency modulation. So instead of changing the amplitude of the signal, it's changing how rapid the signal is oscillating. And that's the frequency change indicates whether it's a 0 or a 1 or a high or a low. That frequency change, as grounds change, noise change, can go up higher and down lower, higher peaks, lower valleys, and it doesn't make a difference in the frequency itself, right? The amplitude doesn't change the actual data signal itself, whereas an MSTP, it very seriously does, as you can see. One of the things that we felt was really important, a lot of people don't understand this coming from the MSTP market, is the importance of cabling, right? MSTP cabling, you have to really be diligent, select the right cable. It can't be just any cable. You can't use speaker wire, right? It's got to be RS-485 cabling. With FT, not so much. In fact, people actually use Cat5 cable. There's other FT specified cabling you can use. You can in fact use your MSTP cable. This is what we're doing to retrofit RS-45 MSTP jobs. We take existing building wire, existing MSTP building wire, backnet controllers on there, and we run free topology across it. I have 2,000 feet of MSTP wire right here. I'm going to connect it on the FT bus, and you will see there's no change in latency. And in fact, before I do that, I want to start hammering the communication network so you can see the packet data. Okay, so I'm going to stop this guy first. I got to switch gears. So many different tools for demonstration. Of course, this is not what you typically do in the real world, right? But so let me stop Niagara because I'm going to steal its connection on the bus for what I need to do. All right. Oh, did that out of order. Third time's the charm. I'm going to start polling this device every second. And we're going to watch the bandwidth and the traffic on the network. I'll disconnect the FT. We'll connect it through 2,000 feet of MSTP wire, and it won't even blink. Connect here. Oops. And I apologize, the computer I'm running this on is actually quite slow. This isn't typical. Okay. Okay. We have a bunch of random number generators on this, just spitting out numbers, right? Just proof of concept. We're polling once a second, a bunch of network variables. And in fact, we can look over here to see how many packets per second. About 100 packets per second. Okay. Now it's connected onto MSTP bus. So I'm literally putting 2,000 feet of other communication cabling that should not typically work onto this bus. If it was MSTP, it certainly would freak out. I had the cable shipped here, but the box, I have to. Luckily, I actually did not get stopped here for it. I thought for sure, you know, they're gonna be like, what is this guy up to? All right, there we go. Right in the middle of this connection, right? From one device through 2,000 feet of wire to the other device, okay? Now let's pull it every second. That is, here we go. Of course, I connected it wrong or something. It works, you know, you test it a million times and it works, and then you do something, you know, live, and of course something doesn't work. Never fails. I must have connected something wrong here. I kid you not, I tested this so many times. And in fact, we did so much testing in-house for this. This is actually this is the most practical. Oh, actually, yeah, MSTP is down. We actually did some other testing in-house. We wanted to really stretch the limits here. We wanted to see how far we can go with this. we had FT connected through alligator clips, running through half-inch copper, through some carrier network communications, to sensor wire, through Cat5. I mean, we just chained it through everything, and it was working. Thank you. Yeah. Yeah, it might not be. Yeah, it's on that. All right, let's try it one more time. You know what I can do is I could disconnect it and reconnect it. But yep, yep, polling is definitely stopped. That's good. Can I see this device? No, I connected it wrong. All right, let me put it back. Let's do this again. And I'll take questions if anybody has questions, by the way. I can multitask. Yeah. It's a 6050 echelon transceiver, or Adesto. What Adesto has done is on that 6050 chip, I'm sorry, that's the processor. The transceiver is an FT-T10 transceiver. In fact, Mr. Knipkamp is an expert in that department. Right. There we go.
If you do it simultaneously, two variables that Sammy talks about, can actually propagate simultaneously both at RS-45 and first pair, and simultaneously on the topology, both DAC and IP, FT, long talk. And if you have all the browsers set up over, you can see all of them simultaneously being updated, both back-end variables and long-talk variables and over IP. With some of all these browsers, you can see all that transpiring data.
Correct.
So you have multiple channels, multiple protocols, all simultaneously. And RS-45. So yes, there's duplication on the topology for backnets, IP, long talk, and long talk. That's three things going on in teaching. Then you have the RS-45.
There we go.
Then you actually proper browsers, go to IP, and you have proper browsers, so you do backend browsing, and you do long-talk browsing, and debugging and zero control. You see all these guys doing for verbal human brand. It's very powerful. So for the installation, you have to do stuff. You can attach these and put them into existing networks. So you can do both a backnet network and do long-range networks. And then you can mix to get the best of both worlds.
On the same table.
Same table, yeah. So essentially, you want to do a communication, you can master slave or backnet, yet use free topology peer-to-peer. Here you are doing master slave and peer-to-peer simultaneously. How do you want to do that? Well, same as an example of lighting. Latency. For example, that's going to show up there. So times the master slave, you have a little latency.
Right.
Certainly with the Ethernet, you have more latency. And to overcome that, you just drop into a free topology where peer-to-peer is gone. Latency disappears as far as being there.
So, guys, I apologize. it worked this morning, it worked last night, and it worked last week. There must be something wrong. You know, there are actually two boxes of cabling, and then there's some connections in between. It must be that there's connections in between are open or something. I apologize. Yeah, yeah. So so my apologies there. Um, let me get reconnected, and then that was the majority of what I wanted to just show you guys today. So if you guys have any questions, you want to learn more about how we do this, what happens under the hood, I'd be happy to demonstrate that for you.
Well, thank you. So, interesting.
Yeah.
These things come together.
Yeah.
It's just too much cable.
It's hard to do these demonstrations, with real world products. They take time to actually put together, right? So it doesn't happen by itself. Okay. Oh, I would certainly expect it to be. I mean, this is not a practice that I think you would want to do voluntarily, right? So using RS-45 bus or MTP bus for FT communications. Let me say this: with Category 4 FT communication wire, you can go about 5,000 feet daisy chained, and with a repeater about 9,000 feet. So you can go quite a distance. Now, if you start intermixing it with other wire, I would conservatively, as an installer, I would cut that in half, right? That's me. You might be able to do much more, and it also kind of depends on the building, right? How you're using existing wire, how well was it installed in the first place? What quality wire was it in the first place, and what elements has it been exposed to? But certainly you can use it, and I think as a building owner, if there's a way to use the existing infrastructure and seriously cut down on your installation costs, that's a big benefit. And so those are the times when we use it, right?
So if we have come across an existing building that got NS, 30, 40 devices, can I go hang some lawn devices, some NFT devices on that same comm channel and use that for communication? What are the drawbacks?
So the question, just to make sure I understand, you have an MSTP bus, and you want to add some of these onto the MSTP bus. Okay, so you can do it if and only if that whole bus is going to change to this transceiver, right? You cannot have MSTP transceivers and FT transceivers on the same wire, right? So you can plan for it. And that's one of the benefits of having MSTP on these, right? So you can start migrating towards this. You can have some number, let's just say VAVs, right? You typically have 30 to 40, 50 VAVs on the floor, let's say. You can start doing chunks at a time. You do 10 at a time, and you're connecting them onto MSTP. At the end, if you want to get rid of any of those concerns with MSTP, with communications, you switch it over, same cabling, land it on the FT trunk, and you're good. Yeah. So. You could if you use the MSTP trunk on it, right? So then it's an MSTP device, right? Not an FT device. Correct, yeah. Now, but if you're trying to get away from MSTP, like I know many of us are trying to, that's a viable migration path. You go onto the MSTP trunk, and then you cut the whole branch over onto FT in one shot, right? If you can afford to do it that way, if you have the time and access, yeah. All right. Thank you all very much.